primarily DS algo, and if we have some time left at the end, maybe probably we can discuss one or two of your projects and dive deep into that, right?
Okay, sir. Yes.
Okay. Cool. So to begin with, let me share you a doc where we'll probably kind of discuss the problem and you can write your solution and all. And you can open the doc and share your screen.
Yes, sir.
Okay.
Yes, sir.
Sounds good. Okay, looks good. Right. So yeah, I think we are good to go. We are good to begin with.
Yes, sir.
Basically, imagine this kind of situation. So like this is a situational based problem. So like assume that there is sort of a business meeting, a business conference, so to speak, between a bunch of people, right? And like they belong to different companies, and each of these folks are having sort of chat with each other to basically kind of know about their business and establish business relationships. Okay, so now like what happens in the real world is in two businesses there can be clash of interest right beforehand. For example, two different companies belong to same type of profession. For example, some like educational tech field or something like that. So essentially, the information what we are given is we are given what all people exist, what all businessmen are present in the conference. Those are represented by some IDs, and you have also been given uh, essentially pairs of these people which have some conflict of interest. So these couple of information you have been given, like the total number of businessmen, that the business people that will be in the conference, and which all pairs have a conflict of interest in between them.
So can I write this like?
Yeah, absolutely. Feel free to name whatever.
Okay. We are given IDs of businessmen.
Yeah, like total number of people.
Okay.
And so if there are say 10 people, then you can assume that IDs will be from 0 to 9.
Okay, sir.
Or whatever based indexing you want.
Okay.
That's up to you. And basically sort of pairs of these IDs representing each pair representing that these two IDs have a conflict between them.
Okay.
Now how will that conflict come into picture? We'll discuss.
Okay. Right. Yes, sir.
So we have a list of pairs of IDs, so to speak, and then so basically the aim of the conference is that people they establish business relationships between them. So basically two people can have establish a business relationship if they don't if they don't have a conflict of interest directly or indirectly. So what I mean by this is, so for example, say zero. Let me give a small example. Assume that 0 and 1 they had a conflict of interest in between them, right?
Yes, sir.
In the list of conflict of interest, you have been given this pair as one. Like one of this pair exists, so 0 1. This is a conflict of interest, and like assume that so the question. So if I were to ask, so basically, and another input would be the. Let me give a small example so that I can explain better. So this is one and this is another, right? So basically, this represents these two people want to establish a business relationship between them, right?
Okay.
So 1 and 2, these don't have any conflict of interest, right? In the list of conflict of interest, we don't see any conflict present between 1 and 2, either directly or indirectly. So 1 and 2 can establish a business relationship. Now coming to the next request, so to speak, 0 2. Can 0 2 establish? So now 0 1 already have a conflict of interest, right?
Okay.
Uh, and so like this is a conflict of interest. So and 2 also has established a relationship with 1, right?
Okay. Yes, sir.
So basically 0 would have an indirect conflict of interest with 2 because 2 is associated to 1,
Yes, sir.
right? And 1 had a conflict of interest with 0. So 0 also has a conflict of interest with 2. So this relationship cannot be established.
Yeah.
Did you get my point?
Yes, yes,
We
sir.
can have direct and indirect, both sort
Yes,
of
sir.
conflict of interest. So
Yes.
essentially, basically, given all this information, given total number of business people, list of such conflict of interest, essentially pairs, you'll be given many of these pairs, and you'll also be given sort of requests of uh, a list of these pairs also. Each pair would represent कि these two want to establish a business relationship, and your
Okay.
output would be for each of these pairs you would return a boolean value true or false, indicating कि whether these two folks can establish a relationship or not.
So, I have a question. Like, we have to assume that if we are going from 1 to 2, and then from 0 to 2, we assume that 1 and 2 have a connection or not. Like, is it like.
So based on what all information you have, so based on all the previous requests,
Yes, sir.
out of all the previous requests, what all connections have been established, you assume that they have been established for all the future requests. So you can treat these requests in a sequential order.
Okay. Yes, sir. Okay. So.
Basically, future requests are dependent on the previous ones existing.
Okay. So, sir, let me clarify one thing on also. We have given the conflicts pair, and we have a query like running on the, and we have to say like if current query is acceptable or not to make a business.
Yeah.
Okay.
Basically, these queries will be in form of a list, right?
Yes, sir.
That entire query list will be given to you. For any query, what all was the result of previous queries, that would also be taken into account.
Okay. Yes, sir. Okay. So. Okay, sir. So we can do like this. We can use the union find data structure, and from there, so we store the conflicts which were given in an undirected way, 0 and 1 and 1 and 0 both. And when we are running the query, we will assume we will just we will make the we will construct a tree, and like 1 and 2 are 1 and 2 have a meeting, so we make parent of 2 as 1, and then we have again have a 0 and 2. So we initialize our parent vector with the same number initially, and since we have updated parents of 2 is 1, so we can't join 0 and 2 because parents of 2 is 1 and we have a conflict between 0 and 1. So,
okay.
And yes, sir, this can solve the question. Should I code it?
No, please wait a second. Let's analyze it further.
Yeah.
Can you take some example and verify the approach?
Okay.
Let's dive a little bit deep before moving on to the code.
Okay, sir.
Yeah, like
Yes, sir. Should I go with?
I want you to like construct some example and run your idea.
Okay, sir. We can take like these pairs have a conflict. I'm writing first. Like we have 0, 1 and 2, 2, 4 and like 3, 5 and we have to like we are given a query of 1, 2 then 0, 5 then we can take any more example like 1, 3 and 2, 5 and some like 2, 4. Yeah. So we will first we will initialize the parent vector with the we will take a vector of parents and we will initialize everyone with the same with their same index as a parent. So so basically the parent of 1 is 1.
Right.
Yeah, in this way, and then we will go with the given query. Since we know in initial parent of 1 is 1 and parent of 2 is 2, and we already stored the conflicts. We will store the conflict in a map in a pair
Okay.
like this, and this is like for a visit for a what mapping for finding the conflict. And what we will do, we will first check the parent of 1. We will find the parent of 1 is 1 itself and the parent of 2 is 2 itself. So we will merge it. And before merging, we will find out first, like, is there a conflict between 1 and 2? We saw that no, there's a no conflict between 1 and 2 because we can't find the pair in our map. So we will go with 3 and we'll give you as true.
Okay.
Then we will go with 0 and 5. Still we will find the same because the parent of 0 is 0 and the parent of 5 is 5. So it again gives me a true. Then we will go with a 1 and 3. Did I take the wrong example? Okay. Yeah. Then we go with the parent of 1 and 3 and there's the same and give you true.
Okay.
Then again we have a 2 and 5. Since we have merged here 1 and 2, we will make the parent of 1 or 2 itself. So for here I can make a parent of uh, parent of 2 as 1.
Right.
So here is like parent of 2 equals 1. And so from here we saw the parent of 2 is 1 and we are at 2 at 5. Parent of 2 is 1 and parent of 5 is 0.
Okay.
So and can we join like another question can we join 1 and 0? So we can join. There is no any conflict between. Yeah, we have a conflict between 1 and 0 at the first case. Yes. This one.
So how are you finding this conflict? Like you are querying from the map of pairs?
Yes, sir.
Directly?
I will just ask, does this pair exist or not?
Okay. So
Yes, sir.
I have a question here. So like basically you are sort of checking the parents for each of the queries, right?
Yes, sir.
So like it can very well be a case
Yes, sir.
the map does not have that exact pair, like because you are sort of mapping.
Okay, yes, sir.
You can't have like it may not be necessary. We have that exact pair. Like we have some ancestor for one of those and some ancestor for the second element in the pair, and that is present in the map. But you are not querying that. You are querying instead the like final parents which you have.
Okay, yes, sir.
Want to like double check.
Yes, sir. Yes, sir. I got it. So let me like check it. Okay. The problem is this. Yeah, what if the parent is 1 or 2? So, okay. And now the checking will be in square. Then, 1.05 into 0.5132524. The problem is like if 2 become 1, then have to become 1 and 5 become 0. Okay. Now the conflict between 0 and 1 into 1 4. So rather going
So maybe like
so
like overall approach seems to be sort of in the right direction. Maybe you can probably take a step back in regards to checking like whether it's possible to check the parents have a conflict of interest in open time or not. Like basically you're querying the map, right? You're querying from the map, right? But
yes, sir.
maybe you can probably think of some way assuming okay, direct querying
It's not
not
possible.
feasible here, so maybe first step can be to not think of a direct query.
Okay.
But yeah, the overall direction seems to be okay.
So since we 1, 2, and 0, okay. So the problem is we have a 0 and 1, and it not might possibly be connected as a query. So 2, 4, 3, 5. Okay, let me just move and so we can just query every pairs, and we make the while querying like I'm going to like travel the whole map,
Okay.
and then while querying I will find the parent of like first and second. This in a amortized way I can find the parent in O1. I will store that parent immediately if I find like during my finding of the parent.
Right.
So we can go through the whole loop, and during the checking of like here's the problem. If what if we give the parent of 1 as 2? So 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 when I was checking for the parent of 2 and 5, parent of 2 itself is 2, and here parent of 5 is 0. So when I loop it over the conflicting pairs, I will go with a 0, and we find the pair of 0 is 0 and the parent of 1 is 2. So yeah, we find the conflict in that way. So but the time complexity will be for the every query will be big of n.
N represents what?
N represent the number of conflicts pair we have.
Okay. So essentially, yeah, right. I did get your point. So essentially, you're querying over the conflict as well for each query.
Yes, sir.
Right. Okay. And so, and you're accommodating the previous queries by merging whenever you get it true.
Yes, sir. Whenever I get it true, I merge it.
Okay. So okay.
Yes, sir.
I think maybe we can like start implementing this approach with this idea.
Okay.
If there is some scope or room for further improvement, maybe we can figure it out. But yeah, as a step one, we can start it.
Okay, sir. So should I just write the function?
Yeah, and like take the inputs and all as you want, like whatever is most.
Okay, sir. Okay, sir. So we have like wild. We have just one to return true and false. Okay. So we will just store the values. So I take it like is an offline way. Like I first take all the inputs and then I give the outputs.
Okay.
Okay. So yeah, I will just void a function here. Function of merging, and here I just name it like this. Function of merging, and I take a input of IDs with Okay, I just take it the vector of int, and it gives me conflicts ID. Uh, Conflicts ID, and we have a vector of pairs. Vector of okay, we just take the pairs. Why should I be taking the conflicts like? Okay, and we have a pair here also. And we take it name as query. So yeah, yeah. Okay, so I will first. I'm making a global variable for the parents. Is it okay? Yeah, is it okay? I'm making a global variable for the parents so that I can access in my all functions. And this is all okay. I need only parent. Yeah, I need only parents. And did I need something else? Okay, let me check it. Okay, and now we have the size of IDs will be. So how we get the number of persons? Should I take an input or?
Yeah, like you can assume.
Okay, int person is like number of inputs. So we have a person like we have this. So I just go for the loop. Uh, I is zero, I less than person, and we're making the parent of itself. So parent dot prospect and that I. So I'm taking the zero based indexing.
Sure.
Now we have to run the query. So we will just loop out the query. Now we have a query and we have to merge x and y, like person 1 or person 2. So int person 1 equals I of 0. Int person. So it auto caps, I guess. Is it okay? Like the first letter is already okay. And since we have a pair, we have to take I dot first and I dot second. So here's the person 1 and person 2. We will find its parent. So I will just find the parent of person 1 equals, I will just make a function to find the parent. So I will write the function after, I will just write the like framework how will I going to write it. So I will just find the parent of person 1. So find the keyword so I have to change its name. And int of parent of person 2 is equal to find person 2. And before merging, we have to check isn't it problem to conflict, like it isn't creating the conflict. So I will just wrote the another function for checking it, whether it is giving a conflict or not. So if I will give the checker function and insert, and as a parameter, I will give them a parent 1 and parent 2. Parent of person 1 and parent of person 2. And if this is true, then we can merge it. So now, okay, so we can make a parent of any one person of anyone else. So,
Yeah, please.
yes, sir. Yeah. So we will make the parent of person 1 equal to parent of person 2. Parent of person 2. Yeah. So otherwise, we will just if it's true, then we will just maintain a one bit. Okay, I can just print true or false. So like I will print true, else I will print false. This is the main function. So now I have to write the about the finding of the parent and the checker function. First, I'm writing the finding of the parents. So, like it will return an integer of parents. So I just have to take a person as a parameter, and we will have to just find like if parent of person equal person, we will return that person. Otherwise, we will first store it and again and find for his parents. Uh, if the parent of one is 2 and the parent of 2 is 3, and we had 1, so we be finding the parent of 1 is 2. Then again we finding the parent of 2 as 3. So we are just returning in that way whatever we are getting as a parent of that person. So
right.
And I'm just storing it so that if again the same query came, I don't have to find again the parent of 2. Like I can directly jump up parent of 1 is 3. So that's why I'm storing it.
Right. So
Yes.
like just to dive deeper into this, so this in find, like this would return the correct answer even if you do a return find of parent person, right?
Yes, sir. But since it like in a querying of my conflicting IDs, I will again go at a 0 and 1. And if n is large, and we again querying the parent of 0 and 1, and if it is a like a single chain, like a single array, so we again like traveling again n for that particular conflict. So it's better to store the value of parent if we are finding at once. So for the next time, it give me in a constant time.
Right.
Yes.
Do you like? Are you aware of what this idea is called?
So it's an amortized way to like.
No, amortization. It's like.
Okay, so path compression.
Yeah, correct.
Yeah, yeah. And now we have the checker function, which is a bull function. So what this checker function will, we have a parameter as a int person 1 and int person 2. We have to check that this is possible or not. Okay, since we have a conflict ID as a parameter here, so we have to take another parameter as a conflict ID. And I'm just copying it. I'm passing it a reference because I just need to check. So this is the same thing which I have to do. I just have to travel the whole conflict IDs. And conflict IDs. What I will do, I will find the same thing, the parent of person 1 and parent of person 2. So I'm just copying it from here. Parent of person 1 and parent of person 2. And here I'm not a parent of person 1 and parent of person 2. I just have to find parent of I dot first. And here I dot second. And here is the parent of like P2 and P1. So we found the parent and we have to check. Um, now, now we have to find the parent of person 1 and person 2 also. So it's better just I'm copying it. It's better I just store it here because I don't have to check again and again for the parent of person 1 and parent of person 2. Since I can just pass it as a parameter also, but since I stored it here, it doesn't matter. It's giving a constant time.
Right.
So it doesn't matter here. So I just to check if parent of P1 equals parent of person 1, parent of person 1, and the another case another person parent of P2 is equals parent of person 2, and I will take a or in other way, like there's a sub between them. So I just take a copy, just copy it here. Paste it here. I have to put another. Just changing it here. P2 and here P1. If this is true, if anyone is just true, we will just return false from here. And if we cover the whole loop and still we didn't like return, so then we will just return the true. And this will just give out our answer.
Right. Okay.
Yes, sir. This is all good.
Right. Cool. Okay. So
Yes.
I think this looks good. Maybe we can what we can do is like assume whatever variable length names you want, like for the size of conflicts array and for the size of conflicts vector and for the size of query. Assume whatever variable names you want, write that down, and for like like go through the entire thing, and for like each of the part, like let's analyze what the time complexity for that portion would be and what the overall complexity analysis would be for the whole thing, for the whole program.
So should I just have to dry run or like I just to take an example? I don't understand that.
Like basically, for like assume the conflicts ID is of size
Okay.
E
Okay.
or query is of size Q, like whatever variable names you want. I basically want to
Yes,
sort
sir.
of get a complexity analysis for each part and then the whole of the.
Okay, sir. Yeah. Okay, sir. If we take the person as like length, total number of person as n, let me write it, sir. It's easy for me. Write it here. Like, should I delete this, sir? It's like everything will accept.
You can write it after that. Like let it be.
Okay, sir. So if we take like person equals n, and we have a conflict ID of like conflict ID size with like number of person equals n, and number of conflict IDs will be m, and we have a query like q, query of size q. So first of all, this is going to be at like this is going to be a big of n complexity for storing the values, and this is a loop which is going to be a big of q complexity, and for finding the finding the parent, we have to go to the log of n. So there's a log of n. This is log of n. That means log of 2n here for the finding the parent.
So
And
what else find log n? Log n?
Yes, sir. It will go in a log n complexity.
Like isn't the amortized complexity for this constant time?
So, but like on an average case, we have to like in a worst case, we have to like travel the whole array. If it like in a linear chain, like is it possible?
Which part are you talking about? Let's just.
What? No, sir. Like this is the finding of the parent.
So, like at each step, you are doing the path compression, right? So basically, it boils down to saying ki, like if you say that this function returns an O log in average complexity, so it boils down to you saying ki
Yeah.
union find path compression algorithm has a log n amortized complexity.
Okay. Yes, sir.
Yeah, so
Found
like
the mistake. Yes, sir.
so
Uh,
it's just like separate discussion further ki the analysis of path
Found finding
compression
the function.
algorithm and all that involves like hyperconvergence functions and all those things.
Yes,
So
sir.
I don't think we can dive into that, but just as a pure concept, uh,
Okay.
what are you aware ki the time complexity of union find is?
So, if if it union find have a complexity of big O of n log n and n square both. So here what I am doing, I'm just assigning the parent without considering that the I'm increasing the chain of increasing the uh, length of the subtrees without any consideration that I'm just randomly giving the parent's name here
Right,
without any considering it might possible that here it is a 5 length chain and here is a 2 length chain
right.
and I'm just joining the to the make it a 7 length chain.
Right.
We can
So what
we
can
can
you like? What step can you? What can you do at this point? Parent of
uh,
parent person one equal to parent of parent person two.
yes sir I
What
can just
can you do to like further like
yes sir
ensure that the amortized complexity also is constant?
yes sir what I can do I have to take another vector like another data structure to store the current height of particular parent. So whenever I am joining, I will assign the parent. If the height is low, if the height of parent one is higher than the height of parent two, then it is like worth it to merge with the parent one and make the parent of two as one.
So
So
can't you
that
assume that? Okay,
yes, sir.
I got your point. So like you can assume the same with like you can assume that lesser ID is more priority, right? Why need a separate height also?
So it depends on how we are querying. If query is random, how can we just go on the indexes?
Hmm. Right.
We have to go with the we have to store the heights of the particular parent so that if we are merging we have to see if there's also possibility there's a different components.
Hmm. Right.
So when we are merging we have to think it like that way. So I can just use the extra data structure to store the ranges and before joining I will compare and increase the one. Like if it's less then I will not increase. If it's equal then I can increase anyone so that this whole will be in a average way it will be like constant time complexity.
And okay. And how about so can you scroll down a bit?
What's it?
Can you
Okay,
scroll
so
down a bit?
yeah,
Yeah.
yeah, yeah.
So how about like let me pose another situation. Instead of doing this parent person one equal to parent person two, how about finding the root of the parent person, finding the okay. So you're doing that and
Yes, sir.
right. Okay, like that makes sense. Ki you are defining some order based on the height of the tree,
Yes, sir.
subtree under it. Makes sense. Yeah, I think that would be like that would lead to more closer optimize, closer quantize of
Yes,
complexity.
sir.
Uh, Still okay. Even I'd say ki if you do that based on IDs, maybe there is some at least some heuristic being defined here. Ki you're always making person with lower ID as the parent of a person with higher ID. So uh,
Yeah, sir, but there's a one case if we always making a higher person mm, as a parent.
right,
So if we are getting 5 4 3 2 1
hmm,
and we make the parent of 4 as 5 3 as 5 and 2 like in a linear chain
right,
and when we get 6
right.
like 5 and 6 so uh, we just talk about wait a minute sir
Yeah,
uh,
feel free to
yes sir
do that with an example.
Yeah, sir. In the same way, like first I will get 5, then 4, then 3, then 2, then 1. Then we already making the chain of 5, 4, 3, 2, 1, and then we get a 6. From according to that approach, we will be making the parent of 5 as 6.
Right? No,
But
but
yes,
when
sir.
you are doing the find, you're already making the parent of 5 as 1. Like when you're calling find, you're doing path compression at every step, right? For the example that you just mentioned, 5, 4, 3, 3, 2, 1.
Yes, sir. Uh, but sir, what if they all are the at a separate component, and like if this is n by 2 and n by 2, and then we are merging. So yes, sir, this can be done. Yeah, this can be done, sir.
Right?
Yeah, this can be done.
Cool. The main thing was key to get whatever key, basically to add on any heuristic. So we discussed a couple of heuristics. So
Yes,
that's
sir.
fine.
Yes, sir.
And with that, you are saying key amortized complexity for that step is constant.
Like we can say like yes, sir. That not a constant, sir. Amortized constant. Like finding the parent will be constant at. I'm thinking, sir.
Hmm.
Like when we are assigning the parent without thinking of the height of the tree, and when we merge it,
Hmm.
uh, at max the height of the tree will be okay. Yes, yeah. This can be done. Yeah, this will be amortized with the constant complexity. Yes, sir. Because of the path compression.
Right. Yeah.
Yeah, sure. Sure, yes, sir.
So yeah, with that analysis at hand, like you can continue with the evaluation.
Yes, sir. So if we take the average complexity of finding the person will be a constant, like something big of k as a constant, like 2, 2, 3, 4, not k is a constant. It doesn't depend upon any variable. So the overall time and the finding the parent of and the first checking is this. We have a check like we have a query of a conflict ID m. So for every for this whole framework for whole this function merging, we are going with the complexity of uh, big O of n plus k. Uh, let me write it here.
For the checker, what would be the total complexity?
Yes, sir.
You did mention for the checker.
Yes, sir. It will be like big of n plus k and plus 8 something m. Um, and for overall querying will be q. This is q times. This is the whole time complexity of the function.
Uh, what was n?
It's a yeah. N is the total number of person. K is for the constant of finding the average time complexity of finding the person like parent.
Why does n come into picture?
So because we are just traveling here. To,
So but this is not for all the queries, right? So you are multiplying this also by q. So you are doing.
yeah, sorry, yes, sir. Sorry, I haven't saw. Yeah, I have to multiply this with q, and this will be the overall time complexity. Let me cross check it. This is an n and the query for I'm doing all the query. This will be q, and for every finding the parent will be o of big of k, and for checking it, I'm just traveling the uh, whole parent, and we'll just and this is all the constant. So yes, sir. This is the overall time complexity.
Okay.
Yes, sir.
Uh, cool. And while you are at it, can you analyze the auxiliary space and all?
Yes, sir. Auxiliary space apart from the input,
Yeah.
yeah. So we are just storing the parents. So it's a number of parents like big of n complexities of the space we are just and anything more? No,
Yeah.
no, sir. We are just storing the parent of the big of n complexity and all the variable we are storing is just a constant space, so we don't have to care about much.
Okay.
So yeah.
Right.
Yes, sir.
Cool. So maybe you can write that as well.
Okay. This is our space. This is our time complexity. There is a number of person.
Okay.
Yes,
Sounds
sir.
looks good. Looks good. Right. So, uh, yeah, essentially, uh, if you think that there is some room for optimization of this, maybe you can think a bit about it. I personally think that this is good enough, right?
Yes.
Maybe there is a possibility of optimization. We don't have enough time to
Yes, sir.
dive deep into that, but still, uh, feel free to take your time after this and dive further. Um,
Okay, sir.
uh, yeah, like I think from a problem perspective, we are through with it.
Yes, sir.
Maybe you can discuss a bit about any of your recent academic projects or any work experience you have had recently.
Yes. I have done a summer training in a Demox Academy where they have taught me the data structure and algorithm, and we have done a project where I used the Node.js and the Express.js for the MVC flow, and EJS for the front end part, where I used the API call for fetching the data, and I deployed it over AWS EC2 instance by configuring it by myself.
Okay.
And
So,
and
what was the what was the theme? What was the purpose of the application?
so to get exposure of the MVC flow, like how model view controller is working, how we are fetching the data from the
Right, right, right. I'm not talking about the tech stack used.
okay.
I'm talking about what was the product itself, basically.
Okay, so we are just if a client can ask the query about any movie, the my web service will show the query of particular movies in a card form, like just like a search query of any movies to know any further detail more. Like
Okay.
client can know by clicking know more for further detail of that particular movie.
Right.
Yes.
So, what kind of database did you use, and how
So
did you establish the connection between your user and that database?
so I haven't used the database because I'm fetching the data from the API.
Okay.
So there's only Express.js for the routing and the server purpose, and for the front end is EJS. So like no database.
Sounds good. Okay.
Yes.
Uh, did you add any? So, while using some external third-party APIs, right, there is a notion to perhaps, it's always good practice to do some error handling in case the
Yes, sir.
API doesn't work or something. So, did you during your
Yes, sir.
implementation did
Yes, sir.
add any fallback in case the API did not return any result, or uh, there is one thing it returns an empty result, but there is another thing that the API call itself fails. So any fallbacks you had
Yes,
to
sir.
do?
I will check that if the status code is not 200. Then I will just send it to the middleware of middleware to handling the error so that it just give the user that something went wrong.
Okay.
Yes, sir.
Right. Cool.
Yeah.
Sounds good. Okay. So yeah, we are more or less uh, on time
Okay, sir.
regarding the interview. So I believe uh, at this point in a real interview we will end the round and
Yes, sir.
basically close the meeting. But
Okay.
yeah, since this is a mock interview, I'll basically the feedback portion on all we generally do on our own, and that is routed to you via some recruiter or something. But in
Okay, sir.
this case, I'll directly like tell the feedback to you and what all points
Yes, sir.
what all points can be worked upon or maybe iterated upon,
Okay,
right?
sir. Yeah.
So yeah, the overall notion, I'd say, pretty decent performance. You, uh, as you you answered the question. You explained it well enough. You uh,
Yes, sir.
like ran it. In fact, created a small test case, ran it over the test case, right?
Yes,
You
sir.
uh, the good point, for this particular question, what worked well was you were able to figure out the approach right off the bat. So
Yes, sir.
that approach, the fundamental idea, that data structure, getting the data structure right, that time was compressed, and
Yes, sir.
you were able to like focus more on writing more readable code, more detailed code, so that
Yes, sir.
the overall time for the interview is like fits within the uh, allocated time.
Yes, sir.
That worked well for this problem, right? From a data structure algorithm perspective, I found that your concepts were good enough, at least for whatever we were able to test for this problem. Like you were able to uh, like answer what all any details regarding the algorithm itself,
Yes, sir.
why you chose the data structure. That also like you gave a satisfactory response, and the complexity analysis was also on par. The
Yes, sir.
data structure algorithm part pretty decent. Code also, I believe your code was readable enough.
Yes.
Probably just as a side note,
Yes, sir.
for this uh, like since we have pairs and all, it generally works. But maybe you can sort of prefer to create a struct or a class for um, other things. So, for example, instead of a pair, you can maybe use a class. In this case, it works fine, like
Yes, sir.
decent enough. But if you are in cases where you are given the liberty to uh, have inputs in your own way, create inputs in your own way,
Yes, sir.
try to use classes, try to use structs, because that gives a more informative description of what is being stored in a vector or in whatever data structure, right?
Yes, sir.
This is a general feedback, like not specific to this problem. For this, it is decent enough because each entity is essentially a pair of its only. Like there is no
Yes.
visible uh, demarcation between the two entities being stored as a pair, right? If there also, if for example, a pair of a weight and a node, something
Yes,
like
sir.
that would have been more apt in a class or a struct, right? With details regarding what each value meant,
Okay, sir.
right? So yeah, code was readable. Implementation was, I think, the speed was fine, and overall interview speed, that was also like we were able to cover the question with the final explanation and everything in duration,
Yes, sir.
right? Um, okay. One like small feedback key. Uh, basically, so you gave a pretty quick one two line summary initially itself, like when you thought of union find,
Yes,
and
sir.
then you were a bit prompt to move directly to the code, and like I had to I had to actively divert you back to sort of analyzing this overall algorithm further, and then later move on to the code. So try to do that proactively. Basically, you explain the idea. Okay, I'll use union find and all. Then try to do what you did after I diverted you back. Okay, let's move. Let's go over an example, and let's see how your algorithm will work. So that what that does is it helps give the interviewer a detailed idea. Okay, before moving on to the implementation, this would be the rough blueprint of the algorithm that the candidate has thought.
Okay, sir.
Right. So always like give at least 5 minutes to explain in detail whatever thing comes to your mind, and if you feel key, you can write an example and explain why I'm moving through that example. That's also a very nice step,
Okay, sir.
right? Because that does two things. It gives blueprint of the algorithm to the interviewer, number one, and second, it uh, like does a walkthrough beforehand itself on the input. So it gives another signal key. The candidate has ability to create test cases, so to
Yes,
speak.
sir.
It's
Yes, sir.
generally preferable to do it after the implementation is over, to create some sort of test case and all, and run over that.
Yes.
So that is also another point key. You can proactively say, "Key, okay, I think this works fine. Would you do you think I can like create small test case and run over that?" So
Okay, sir.
that also works well
Okay, sir.
in some cases. Right?
Yes, sir.
Uh, Let's see what else. Yeah, I think that's all I can think of right now. Maybe if I have something else, I can relay it back to you.
Yes, thank you, sir.
Okay. Um,
Yes,
cool, yeah, and maybe like your code is readable enough, but yeah, try to
understood.
emphasize on that. You can take a look back at your code and think, and definitely point out if there are any points where you could have improved the readability. Do make a note of that so that in future that readability is at par
Yes.
with the current version or is improved further.
Okay, sir.
Right?
Okay,
So
yes.
I think yeah, and the project part and all, I think you gave a satisfactory explanation and you answered the questions. Like it gives an indication, okay, you are aware of the things
Yes,
that.
sir.
Okay, so that's all the uh, information I had to give regarding the interview. Overall, I'd say well done and
Thank
all
you,
the
sir.
best for your upcoming rounds, whatever you have.
Yes, sir.
Before